38 beneath the Earth's surface. You probably already gotten directions from your teacher, but the goal is here to read and then stop and answer some questions on the worksheet that you've been given and then continue on. You can choose to do it that way if you want to, or any way you want to that works the best for you. I just thought that I would record the reading for you because I know that sometimes this textbook has some difficult pieces in it. So here we go. When volcanoes erupt, magma is released. Where does this magma come from? To answer this question, it helps to know more about the Earth. You can see from this picture, there is the surface, there is the center. This is supposed to represent the Earth. Imagine taking a glass elevator to the center of the Earth. What would you see? Here is that glass elevator. The challenge is, what is beneath the Earth's surface? These are the things that you're going to need. Now I'm moving to page D13. It says on the top here to use student sheet 38.1, talking, drawing 1 beneath the Earth's surface to help prepare you for the following reading. On the Earth's surface, a volcano is an opening in the Earth from which magma and gas erupt. Gases within the magma build up enough pressure to force it upwards and eventually through gaps in the Earth's surface, causing an eruption. Once magma has erupted onto the Earth's surface, it is called lava. As it cools, the lava forms volcanic rock. Over time, volcanic rock and ash can result in a hill or mountain around the opening. This resulting landform is also called a volcano. Volcanic eruptions are not all alike. Some eruptions are gentle, with lava slowly seeping from a vent. Other eruptions are violent, with lava, ash, and other materials being hurled hundreds of kilometers into the air. Differences in volcanic eruptions result in different volcanic mountain shapes, such as shield volcanoes, cinder cones, and composite volcanoes. You can see examples of each of these shapes in the photographs on the next page. There is a lot of evidence of volcanic activity on Earth. Many mountains have been formed from volcanoes that are now extinct or dormant. Yucca Mountain was formed from volcanic material exploding from a composite volcano that is now extinct. The 7 dormant volcanoes near Yucca Mountain are cinder cones. Here you can see in this picture, the scientists who study volcanoes are known as volcanologists. These volcanologists are measuring the temperature of an active volcano. I think I'd have some better shoes on than that. Moving to D16. You can see here the examples that they were talking about. I'm going to make my picture a little smaller so you can see all 3 of them at the same time. Here is this first one. It is called a shield volcano, such as Oregon's Mount, looks like Bachelor, shown here, usually form large, broad volcanoes. These release relatively fast-moving, less gassy lava and tend to have less explosive eruptions than other types of volcanoes. People can often walk fairly close to these erupting volcanoes. So there's some things that you should know about shield volcanoes, and those things should go in your notes. The next one it talks about are cinder cones. The smallest and most common volcanoes are called cinder cones. They are formed from explosive eruptions that shoot small pieces of magma and ash into the air. The magma then cools and hardens as it falls back to the earth, forming a cinder cone. In many cases, cinder cones form on the sides of larger volcanoes. This photo shows a cinder cone on Mount Etna in Italy. Again, one type of volcanic, I can't talk, one form of volcanic landform that's created, and you should know the characteristics of a cinder cone. And the last one is a composite volcano. They have explosive eruptions as a result of more gassy magma. They are formed from layers of lava and ash. Composite volcanoes are also known as stratovolcanoes. This photo shows Mount St. Helens, Washington, a composite volcano before its 1980 eruption. Going to the next page. Inside the Earth. Early evidence about the inside of the Earth came from volcanic eruptions. In the last 100 years, scientists have been learning more about the Earth using technology and new methods for gathering evidence. For example, scientists have learned a lot from studying earthquakes. Earthquake waves move through different materials in different ways and at different speeds. In general, these waves move faster through more dense solids than they do through less dense solids. The waves move slowest through liquids. Scientists, such as the one shown below, measure the waves from a single earthquake at different places on the Earth's surface. By analyzing and comparing the data from many earthquakes, they have been able to determine the state, solid, liquid, or gas, of the material inside of the Earth. Some important information from that paragraph, again, ought to be included in your notes. Scientists now know that rocks on the Earth's surface are only a tiny fraction of what makes up the planet. Think of the Earth as an egg. The thickness of the eggshell would represent the thickness of all the rocks at the surface. Beneath an eggshell there is egg white and yolk. What is beneath the rocks at the surface of the Earth? Research indicates that the Earth has 3 layers: a crust, a mantle, and a core. The core is made up of both a solid and a liquid layer, which are usually described separately as the outer core and the inner core. Information about each of these layers is summarized in the table on the next page. So I'm going to D18 now. You can see on D18 they're talking about the table. You can see over on the left-hand side the different layers of the Earth: the crust, the mantle, the outer core, and the inner core. And then the next column, you see the approximate depth below the surface in kilometers. So you can figure that out, what that means there. Then in the third column is the state of matter that layer usually is. The fourth column is the material that layer is made up of. And the fifth column is the temperature in centigrade. You can see going all the way from 0, possibly up at the top, to over 6,000 degrees Celsius. Remember, that's not Fahrenheit. That's a little different. So to continue reading, the magma that erupts from volcanoes often comes from the mantle. Magma rising from the mantle can collect in underground chambers in the Earth's crust, building up pressure before exploding toward the surface. The mantle is almost 3,000 kilometers thick, which is about the same as the distance from New York City to Denver, Colorado. The land from New York to Colorado is not always the same, and neither are all the parts of the mantle. The uppermost part of the mantle is more solid than the lower part, because the upper mantle and crust are both solid. Geologists have a name for the combination of these 2 layers: lithosphere. Litho means stone in Greek, and the lithosphere refers to the first 100 kilometers below the Earth's surface. So in the analysis portion of this activity, you are asked to identify which layers of the Earth are or is A, the hottest, B, the layer that's at the Earth's center, and C, the layer that is completely solid. Number 2, it's asking you to copy the 5 words shown below. You can see all 5 of them. A asks you to look for a relationship among those words. Cross out the word or phrase that does not belong with the other 5. Circle the word or phrase that includes all the other words. Then C, and this is the part that you like to forget, explain how the word or phrase you circled is related to the other words in the list. Then if you look down at the next section, this would be the directions for number 3. I'm going to give you, or somebody's going to give you, the student sheet 38.2, talking drawing 2 beneath the Earth's surface, and you're going to use it in the information from the reading to answer questions 3 and 4. You're going to answer parts A through H to create a scaled drawing of the Earth's layers on your student sheet. If you have time, you may want to color it in different layers. A, it's asking you, well, actually, A through H are all asking you to do a different step. Read them carefully. Make sure that you follow each of those steps to the best of your ability. Then you get down to number 4. It says, at Yucca Mountain, nuclear waste will be stored at a depth of about 3/10 kilometers, or 300 meters, or 1,000 feet. So it's asking you in A, in which layer of the Earth will the waste be stored? So use these measurements to determine what layer that is. Then on your worksheet 38.2, place an X on that layer of your drawing so that it's identifiable. And number 5, if your teacher has you do this, compare your drawing on student sheet 38.1 with your drawing on student sheet 38.2. Describe the Earth's interior and explain how your understanding of it has changed. So from the first time you did it in 38.1 to the second time you did it in 38.2. So if you have any questions, please make sure that you ask. I don't know whether you're going to have to do all those analysis questions or not. It's up to your teacher. Have a good day. Thanks. Bye.